Hi class. I love Legos. I play with them with my kids quite often. And I was thinking, Legos are a lot like fractions. With fractions, you can take them apart and put them together and divide things. And same thing with Legos, you can divide things, take things apart, put things together. And in today's lesson, we're going to learn how to compare fractions and add fractions with pictures or displays, diagrams, and it's what's kind of like these two fractions. These two Legos right here. I have this gray Lego and this white Lego, and when they're apart from each other, to know which one is longer and which one is shorter, it's kind of hard to tell. Sometimes you have to put them right next to each other to find out which one is longer than the other. And you can see here, it looks like the gray one's long. When they're apart, it was kind of hard to tell. Put them together, oh, I can tell. Well, fractions, a lot of times, you do the same thing. We'll take drawings or pictures and we'll put them right next to each other, see which one is longer than the other. Also, when we add fractions, a lot of times we just get some pieces and we put them together, and just like we add Legos and we make things longer. Oh, look how long this is now. But with fractions, you gotta make sure they're the same type of fraction. We call them like fractions. It means they have the same denominator. It means they have the same bottom number. But if you kind of like this. I have a piece here that sticks together, comes apart, just like Legos. They seem to work the same way. Well, they should attach, right? So I try to attach them and they don't seem to attach. Well, even if I get one that's the same color, that doesn't seem to matter either. So when we add Legos, you must add them with other Legos, and we add fractions. You have to make sure you add it with like fractions, with fractions that have the same bottom number. And you're gonna watch a video soon with Rob from Math Antics, and he's gonna show us a little bit more how to compare fractions with pictures, and also how to add fractions that are the same, have the same denominator. I'll see you in a bit.
Now that we know how to use fractions to represent parts of a whole, there's a few different things we can do with them. First of all, we can compare fractions. Comparing fractions means checking to see if one fraction is greater than, less than, or equal to another fraction. That's pretty easy if we think of fractions as parts of objects and draw pictures to help us see what we have. Here's an example. Which of these fractions is greater, 3/8 or 5/8? To answer that question, let's start by drawing two rectangles and divide them into 8 equal parts. Since the rectangles are divided into 8 parts, each of those parts is called an eighth. Now, let's shade 3 parts of the first rectangle, or 3/8, and 5 parts of the second rectangle, or 5/8. Our picture makes comparing these fractions easy. You can see that 5/8 is greater than 3/8 because more of that rectangle is shaded. Okay, now let's try one that's a little harder. Which of these fractions is greater, 3/4 or 4/5? Well, let's start again with two rectangles, but this time we need to divide them up differently because the fractions we're comparing have different bottom numbers. The first rectangle will be divided into 4 equal parts, and we'll shade 3 of them to show 3/4. The second rectangle will be divided into 5 equal parts, and we'll shade 4 of them to represent 4/5. Now to compare, all we have to do is see which rectangle is shaded in the most, and that tells us that 4/5 is greater than 3/4. There, that wasn't so hard after all. All right, let's try one more example. Let's compare the fractions 1/2 and 2/4. Again, we start by drawing rectangles and dividing them up into parts. 2 on this one and 4 on this one. Next, we shade the parts of the rectangle according to our top numbers. 1 on this one and 2 on this one. Now, all we have to do is compare. Well, what do you know? The same amount of each rectangle is shaded. That means these two fractions are equal. It might seem strange that two fractions can have totally different numbers and still represent the same amount, but they can. Fractions like that are called equivalent fractions. Equivalent fractions have different top and bottom numbers, but are equal in value. We'll learn more about equivalent fractions later in this video, but for now, let's find out what else we can do with fractions. Another thing we can do with fractions is add them together. Any two fractions can be added, but for now, we're only going to add fractions if they have the same bottom numbers, because those fractions are much easier to add. Like these two fractions, 1/4 and 2/4. Let's add them together. Again, we can use drawings to help us solve this problem. Looking at the rectangles for these two fractions, we can add them visually just by rearranging the parts. Because all of the parts are fourths, our answer will also be fourths. We can just take this 1/4 from over here and combine it with these 2/4, and ta-da, 3/4. So 1/4 plus 2/4 equals 3/4. Let's try another one. Let's add 3/8 to 5/8. Now we can use any shape we want, so I'm going to use a circle this time. So we have 3 out of 8 here and 5 out of 8 here. Just like our last problem, we can add these by combining the parts. So let's put these 3 over here with these 5. And well, what do you know? That fills up all 8 sections. So 3/8 plus 5/8 equals 8/8, or 1 whole circle. In those examples, you might have noticed a pattern. The bottom number of our answer was always the same as the bottom numbers of the fractions we were adding. And the top number of our answer was just the sum of the top numbers of those fractions. Well, that's how it works. That's the procedure or set of steps for adding fractions that have the same bottom numbers. That's important because if you can remember that procedure, then you won't need to use drawings to help you add fractions. And that's a really good thing, because what if you had to add these two fractions together? 1500ths and 1000ths. It would be way too much work to draw rectangles and divide them up into 100 parts. Fortunately, since we know the procedure for adding fractions, we can do it without the drawings. First, let's write out the problem. Now, because we're adding fractions, we know that the answer will also be a fraction. The bottom number of our answer will be the same as the bottom number of the fractions we're adding, 100. And the top number of our answer will just be the sum of our top numbers, 15 plus 10, which equals 25. So as you can see, adding fractions with the same bottom numbers is easy when you know the procedure. All of this brings up a really important point. When you're first learning about fractions, drawing pictures and imagining that fractions represent parts of cookies and candy bars can be really useful, and it can taste good too. Thinking of them that way can help you understand how simple fractions work, and it can even help you solve some basic math problems. But soon, you'll have to do harder math problems. And to solve those, you'll need to stop thinking about fractions as just parts of things and start thinking about them in a different way. Before we move on, let's review what we've covered so far. We can draw pictures to show how fractions represent parts of a whole. Using drawings, we can compare fractions to see which one represents the greatest amount. If we compare two different fractions and find that they represent the same amount, then we call them equivalent fractions. We can also use drawings to help us do simple addition by combining the parts. By doing this, we learn that the procedure for adding fractions that have the same bottom number is to just add the top numbers and keep the same bottom number in our answer. Now, to make sure you understand how to compare and add fractions visually, be sure to do the exercises for this section. Learn more at mathantics.com.
All right, now it's time to practice what we've learned. Let's look at problem number 1. It says compare these fractions visually. So when we look at the pictures here, we need to identify which picture is for which numbers down here. One way to do that is to first look at what has this shape been divided into. Divided means the denominator. The bottom number is what's divided into. So if I look over here, I have 1, 2, 3. It's divided into 3 pieces. So that points to the 3 here. How many of those pieces do I have? How many of those divided pieces I have? Is I have 2 of them. These 2 right here. So that's what points to there. So we know that this is 2/3. Well, then obviously this must be the 3/4. But if we look here, it's been divided into 1, 2, 3, 4 pieces. And there's been shaded 3 of them. So the divided part is the 4. The shaded part is the 3. So now when I compare these fractions, I look over this area and I can see that, well, if I draw this line up here, this is obviously longer than the other piece, so it's bigger. So my 3/4 is bigger. And when I draw the inequality symbol, I have a greater than, less than, or equal to. I can say that 3/4 is greater than 2/3, but I want the mouth I call it the mouth of the symbol to eat the bigger one. So it looks like a mouth. I want to eat this 3/4 here. And so, but when I read from left to right. So listen how my words change. I say 2/3 is less than 3/4. If I read the other way, this way, which we don't read, I could say 3/4 is greater than 2/3. Either way, it means the same thing, but we do read left to right. So we would say 2/3 is less than 3/4. Let's go on to problem number 2. So I look at this, I see how many is divided into. How many pieces is this divided? So I can count 1, 2, 3, 4, 5, 6, 7, 8. Look down here, I see that's my denominator, is 8. And how many are shaded? Well, there's 1, 2, 3, 4, 5. So 5 points to the 5 here. That's how many I have. And this other one is, been cut up into 2 pieces, so it's divided into 2 pieces, and I have one of those pieces right there. So when I compare these 2 pieces, I can definitely say that, if I draw a line here, that 5/8 is greater than 1/2. And so I want the mouth eat the bigger piece. And I do read left to right, so I say 5/8 is greater than 1/2. Let's look at problem number 3. So this represents 1 out of my total 1, 2, 3, 4. So that's my 1/4, and this is 1/4, and it looks like I'm adding them together. So when I have the same, if the image or the shape is divided into here fourths, and the other one's divided into fourths, means the denominators are the same. That means I can connect them, or I can add them together, or subtract them. Just like my Lego pieces, they have to match up. So because they match up, I can still write the 4 over here, because I know I'm going to have 4 still. But what I really want now is, I really only want to add the numerator. So I have 1 plus 1 gives me my 2. So that's how I get my 2/4. The denominators have to be the same. So every time you add or subtract, you must look at the denominator, which is the bottom number, and make sure that they are the same number. If they're not, you cannot add or subtract them until you change them. And we're not doing that in this lesson. That'll be a different lesson. We show you how to change the denominators to where you can actually finally add them. But right now, for this lesson, they're all the same. But it's good to look. So here I have 3 and 3, they're the same, so you have thirds and thirds. So I know I'm going to have thirds down here, but how many of those thirds am I going to have? All I add is the numerator. So I have 1 plus my 2, and 1 plus 2 is 3. So I have 3 of my thirds, which is the same thing as saying 1. I have 1 whole. On number 5, they don't give me the picture anymore, but that's okay. I can just say, are these denominators the same? Yes, they are. So I know my denominator is going to be the same down here, because I know I can't add fractions or subtract fractions if they don't have the same denominator. But on my numerator, that doesn't matter. Those I can add or subtract. In this case, I'm adding, so 1 plus 3 is 4. So I have 4/5 as my answer. Number 6. I have 9 and 9. So I know my denominator is going to be a 9. In my numerator, which is the top number, I have 3 plus 2. And I know 3 plus 2 is 5. So my answer is 5/9. And right here it says, always good to read in the directions, subtract these fractions by procedure. So if I subtract these fractions, I don't subtract the denominators, they stay the same. Because remember, all I care about is the numerator on the adding or subtracting. I can't do it if they're not the same, the denominator, but in this case they are. So 7 minus 4 is 3. I get 3/10. The denominator is the same, so that's good. I just write 15 on this side, and now I want to go 10 minus 8, and 10 minus 8 is 2. 2/15.